Okay, so let's look at challenge 27. This, again, is a fairly simple algorithm. However, there's quite a lot of information to break down, and it does make the sort of calculations involved a little bit complicated, but hopefully this helps you to understand what exactly you need to do. So we're just going to follow the same steps that we always do, which is to look for what inputs we need to start with. So read the whole algorithm and you'll find the word input, and you can see that we are going to input number of passengers, distance. Both are input as whole numbers, which means we know that they're going to be integers. It also says that we're going to calculate the cost of the journey and output the cost. So as a whole, we're going to need 3 different variables as part of this particular algorithm, and then there is one thing that you could store as a constant, which is the £3 that is for the first kilometre, but you don't have to do that. So we're going to just start off by reading through this carefully. So it says the cost of a daytime journey is £3 for the first kilometre and £2 for every kilometre after that. So that straight away makes you think that, well, if they're only going to travel 1 kilometre, then the only thing you need to do is say that the cost is £3 and that's it. But anything that's over, so anything that's greater than 1 kilometre, means that we need to add 3 to the price at the end. But also it says for every kilometre after the first one, so we need to also subtract 1 from the distance if they are more than the first kilometre. So if they're more than 1 kilometre, it says if there are 5 or more passengers in the taxi, an extra 50% is added to the charge as well. So that's just another if statement that we need to go through. So we can see that we're going to have one condition, which is about the distance being over 1 kilometre, and we're also going to have another condition if there are more passengers, 5 or more, then you get this extra charge. Okay, so let's have a little go at programming this now. I'm going to start off with the simple part, which is to create our variables, number of passengers, and distance. We also know that there's going to be a cost as well, so we'll put that in for now. Number of passengers, it says that they need to be input as whole numbers, it says here. So based on that, we need to put them in as integers. So we're going to put int input, a little message to the user, and I'm just going to copy and paste that before I put my message in. So enter number of passengers and enter journey distance. Okay, so now we know that the cost is going to be £3 as a minimum, but we need to look at what the distance is going to be first. So we're going to say if distance is less than or equal to 1, then the cost is going to be 3. That's quite easy. If distance is greater than 1, then cost equals the first 3 plus distance minus 1 times £2. So we need to take 1 off the distance so that we get the updated distance after the first kilometre, and we need to multiply that by 2. Okay, now we could put our else statement in and just say that if they've typed anything else for distance, then there must be some sort of mistake, so we're just going to print an error. It's always just good practice to do that, because you're basically allowing yourself to think a little bit more about what you want the other conditions to be. Obviously in some situations there's only one possible thing that they can input, and if it's not right then it's going to be the else statement. Okay, now at this point we're going to move down onto the next line, and we need to check the number of passengers. So we're going to say that if the number of passengers is greater than or equal to 5, then cost times $1.5. Now if you're a bit confused by what cost times 1.5 means, is it's adding 50% to the charge. By multiplying something by 1.5 it adds an extra 50% on. That's the quickest way of actually calculating it. And again, this is one of those things where you could say elif number of passengers less than 5, but we don't actually need to. It's just if it's anything other than greater than or equal to 5, then the cost stays the same. Now I've put that, which isn't actually necessary to do, but it's just to help you understand the logic as we go through the program. So now we've got print the cost of your journey is I'm also going to put in the little thing we talked about before on each of these lines so that we know that it's going to go on another line. Okay, so now we run the program and it's going to ask them to type in number of passengers and the distance. If the distance is less than or equal to 1 kilometre, then the cost is just £3. If the distance is greater than 1, then the cost is the £3 plus whatever the additional kilometres are multiplied by 2. And if they type something incorrect in somehow, then it will come up print error. If the number of passengers, so this is a separate if statement now, if the number of passengers is greater than or equal to 5, then we multiply the cost by 50%, and if it's not greater than or equal to 5, then the cost is equal to whatever cost already is. We don't need to add any sort of additional charge, and at the end we output what the cost is. Now technically this line here with the else cost equals cost isn't really doing anything, it's just leaving something exactly as it is, but it helps you to understand the logic of the actual algorithm. So we're just going to run this to make sure everything's okay. We're going to enter the number of passengers, so I'm going to say 3 for the first go, and we're going to say 1. Now if the number of passengers is less than 5, that means there's no additional charge, and if it's just 1 kilometre it should just be 3 is our output, which is correct. Now if we do it again, and we'll do a slightly different test. So this time we are going to test, we'll stick with 3 number of passengers, but this time we'll say 10 kilometres, and that should have the original £3 plus 10 minus 1, which is 9, multiplied by 2. So it should be 9 multiplied by 2 is 18, plus 3, it should be 21 is the output. And it is. And the last one, we're going to run a test to see whether it works with 5 or more passengers. So we're going to do 5 passengers, 10 kilometres. Now this time it should add an additional 50%. So if it's £21, it should add an additional 50% of that, which should be additional 10.5 added on. So we should have 31.5, which is correct. So now we know that that algorithm is fully functional. So hopefully by structuring it in this format, it makes it easier for you to see. When we get to this particular part of the program, sometimes in the exam you might see it written as with a comment. You might see end if written down in the program, and that is basically whenever that if statement takes place, that is the end of this original if statement. So this is where it begins, this is a continuation of it, and this is where it ends. So when we move down to the next one, that's why that one is if and that one is elif, because this is all part of the same kind of logical if statement, and this is where it ends, and now we start a completely separate statement. So if those lines were numbered, you'd have number 1, number 2, number 3, and then this would only move on to number 4 if this condition was met. Otherwise, it would go to the next condition, and if that one wasn't met, it would go to the next condition. But after that point, it would automatically go to this or this. So that is what we call program flow. It's how the program flows through. What order does it do the actual lines of code in? And that's why I've structured it in that way, so that you can easily see how that relates to this original algorithm.